I'm going to solve free response question number 3A from the 2022 AP Calculus BC exam, but I'm not going to do it the usual way, where we find these values using definite integrals. Instead, I'm going to do it by finding antiderivatives. So here we have our differentiable function f, and here's our graph of f prime. So what I'm going to do is write an equation for f prime. So we have f prime of x, and I'm going to do f of 0 first. So we were told that this is a semicircle right here. So we want to write the equation of a semicircle. So this is going to be the square root of the radius squared minus x minus 2 squared. That's because this semicircle is shifted 2 units to the right. Then also it's below the x-axis. So I have to make this negative. So this is our equation for the semicircle right here. And this is good when x is between 0 and 4. So this is the equation for f prime of x when x is between 0 and 4. So now to find f of 0, I can just find f of x, use this initial condition, and then plug in 0 and get a value for that. So to do that, I'm going to integrate both sides with respect to x. Alright, so on the left side, when we integrate f prime of x, we get f of x plus a constant, but you know we're going to integrate the right side too, and we'll also have a constant. So I'll just put down a constant at the end when we integrate the right side. Alright, now to do this integral, it's actually kind of difficult. We have to use trig substitution. Let me just explain the concept of that a little bit. By the way, when we find f of 5, it's going to be much easier. So for the trig substitution, we will use an identity. We know that 1 minus sine squared theta equals cosine squared theta. This is the Pythagorean identity. Just, move the terms around a little bit. So what I'm going to do is take a substitution. I'm going to take this x minus 2 right here and make it not just sine theta, but because I have the 4 right here, I have to have a 2 right here. And I'm going to show all the work for this. Once you get some experience doing trig substitutions, you can do a lot of the computations in your head, but I'm going to show all the work for this. Differentiate both sides. We get dx equals 2 cosine theta d theta. All right, so this is going to be the integral. We have the negative. I can put that in the front. So we have negative integral square root of 4 minus, and then the x minus 2 is 2 sine theta. And then we have to square that. And the dx is 2 cosine theta d theta. Let me draw a little separator here so we don't get confused. All right, now let's work this out. We have f of x equals negative. All right, I have this 2. I'll bring that to the front of the integral. So we have negative 2 integral square root. All right, when you square 2 sine theta, you get 4 sine squared theta. I'm going to factor out the 4 from both terms. So we have the 4, we have 1 minus, and then remember, this right here is 4 sine squared theta. So when we factor out the 4, we just get sine squared theta. And then I brought this 2 to the front, so we just have the cosine theta d theta left. All right, so we have f of x equals negative 2 integral. All right, we have the square root of 4, which is 2. And I'm actually not going to take that 2 outside the integral. You'll see why shortly. All right, and then the 1 minus sine squared theta right here, which we still have left in the square root, that comes from this identity right here, which is cosine squared theta. And now you can see why I did this substitution. Then we still have the cosine theta d theta out here. Because now we can cancel the square and the square root, like that. All right, so let's keep going here. We have f of x equals negative 2 integral. All right, so this is cosine theta. Now we're multiplying with this cosine theta as well, so we're going to have cosine squared theta, and of course we still have this 2 right here, which I'll leave like that. And then we have the d theta. Now, how can we integrate cosine squared theta? Well, let's take a look at another angle identity here. We recall the double angle formula for cosine. We know that cosine of 2 theta, well, there are a few formulas. I'm going to use this one, 2 cosine squared theta minus 1. Then I'm going to add 1 on both sides. I get 2 cosine squared theta. equals cosine of 2 theta plus 1. So this right here is 2 cosine squared theta. I can replace that with this. So let me move this down so I have some more space. All right, so we have f of x being equal to negative 2 integral. The 2 cosine squared theta, I can replace that with cosine of 2 theta plus 1. And now we can actually integrate this. We can find an antiderivative. So f of x equals negative 2, and then I'll open up parentheses for the result of integration. Integrating cosine, we get sine, and we'll keep the inside the same. But don't forget to do the reverse chain rule, because the derivative of the inside here is 2, so don't forget to divide by 2, because we're doing the antiderivative, so we'll put a 1/2 down right here. All right, so that was the antiderivative for the first term. Then for this term, we're integrating 1 with respect to theta, so that becomes theta. And here I will put down the plus c. All right, now I'm just going to clean things up a little bit, and eventually we're going to put this back in terms of x. So we have f of x. I'll distribute the negative 2, so we have negative 2, and of course this 2 will cancel with that when I distribute it, so we have negative sine of 2 theta. And then distributing the negative 2, we have minus 2 theta, and then plus c. All right, now let's look back to our original substitution. We assigned x minus 2 to be 2 sine theta. Let me write that down again. So we have x minus 2 equals 2 sine theta. I'm going to divide both sides by 2, so I'll get sine theta equals x minus 2 over 2. Now I can draw a right triangle to relate this to other trig functions. So here's a right triangle, here's right angle, here's the angle theta. So we know that the sine of this angle theta is x minus 2 over 2. So the sine is opposite over hypotenuse. And to get this leg, we can use the Pythagorean theorem, square root of the hypotenuse squared minus the other leg squared. And yes, this is the same as the original that we were integrating, and this is not a coincidence. All right, now let's work this out. F of x equals, we have sine of 2 theta. I don't really know how to deal with the 2 theta, but I can use the double angle identity for sine. We know that sine of 2 theta is the same as 2 sine theta cosine theta. Then we still have the minus 2 theta and the plus c. Okay, so we have negative 2. Sine theta is this, x minus 2 over 2. Cosine theta, to get cosine theta, that's where the right triangle comes in. Because cosine theta, in the right triangle, cosine is adjacent over hypotenuse. So it's going to be adjacent over hypotenuse. All right, then we have minus 2, and theta, to get theta, we can take the inverse sign on both sides here, and we'll get theta is the inverse sign of x minus 2 over 2. And then we still have the plus c. All right, so now we have a function for f of x. And just make a little simplification here, I'll cancel out these 2's. Okay, so now we can use the initial condition to solve for c, and then we can solve the problem. So the initial condition, go way back up to the top to find it, was f of 4 equals 3. Let me write that down here. So we have f of 4 equals 3. All right, so f of 4, so I plug 4 into all the x's right here. So we're going to have 4 minus 2 times the square root. Oh, by the way, this is negative right here. Square root of 4 minus, all right, well, put 4 in here. 4 minus 2 is 2. You square that, you get 4. It's over 2. And the nice thing about this is just 0, so it knocks out this whole term. All right, and then we still have to put 4 in here, so we have minus 2 inverse sine. All right, 4 minus 2 is 2, over 2 is 1, then plus c. All right, and we know that by our initial condition, this has to equal 3. So we have f of 4 equals 3. All right, the inverse sine of 1 is pi over 2. Multiply it with this 2, you'll get pi, but it's negative. So we have negative pi plus c equals 3. Add pi on both sides, we get c equals 3 plus pi. Okay, so now I can take my formula here for f of x and substitute the c back in. So all in all, we have f of x equals, all right, so this is negative x minus 2 times the square root of 4 minus x minus 2 squared, and this is over 2. And then we have minus 2 inverse sine of x minus 2 over 2, and plus c, and c is 3 plus pi, so we'll put plus 3 plus pi. All right, so now we have a formula for f of x, and now we can answer the first part of the question. We can find f of 0. We cannot use this formula to find f of 5, because this is only good for x between 0 and 4. But we can use it for f of 0. So to find f of 0, we'll just plug 0 in here. So f of 0, all right, let's do this. Plug in 0, we get negative 2 square root 4 minus negative 2 squared over 2 minus 2 inverse sine. We have negative 2 over 2 plus 3 plus pi. All right, now this is an answer, right? This is just a number, but I'm going to simplify this to make it look more like what we got last time. All right, so I'm going to cancel out this and that, and of course these negatives become positive. And actually, let's see, you square negative 2, you get 4. So this becomes a 0 again. This term goes away. All right, the inverse sine of negative 1 is, well, the inverse sine of 1 was pi over 2, so the inverse sine of negative 1 is going to be negative pi over 2. All right, so you multiply it with negative 2, you end up with positive pi. And then we still have the plus 3 and the plus pi right here. And all in all, we get 3 plus 2 pi. And this is indeed the same answer that we got last time for f of 0. All right, now we have to start over and find f of 5, but I'll tell you that finding f of 5 is much easier. So to find f of 5, again, we're going to look at the graph here of f prime, but this time we care about this segment. And we're told that this is a line segment. And it's pretty easy to see that the slope is 1, go up 2 over 2. So I'm going to write an equation for this. So this is going to be f prime of x equals, and this line is just y equals x, but it's shifted to the right by 4. So in other words, this is going to be x minus 4. And this is for when x is between 4 and 6. All right, so we can use this formula to find f of 5. And as I mentioned, this is going to be much easier when we do the integration. So we're going to integrate with respect to x, integrate with respect to x. All right, integrating f prime of x, we get f of x plus a constant, but again, I'm going to put the constant down on the right-hand side. All right, integrating x, we get 1/2 x squared. Integrating negative 4, we get negative 4x, and then we'll have the plus c right here. And now we're already done, and we can use the initial condition. So we know that f of 4 equals 3. So we know that f of 4 equals 1/2, plug in 4. And we need this to equal 3. All right, let's just work this out. We have 4 squared is 16. Divide by 2, we get 8. 8 minus 16 is negative 8. Then we have plus c equals 3. So that tells me that c equals 11. So I can plug that in right here. Get f of x equals 1/2 x squared minus 4x plus 11. And now we're already ready to find f of 5. So to get f of 5, we'll just plug in 5. So we get 1/2 of 5 squared minus 4 times 5 plus 11. And again, I will work this out to show that we get the same answer as we did last time. So we have 5 squared is 25, and then we'll divide that by 2. And then we have minus 20, but I want to get the common denominator, so I'll put down 40 over 2. and the plus 11 will have the plus 22 over 2. And then just work this out really quickly. We have on the top, you know the bottom is going to be 2. The top we have the 25 plus 22, that's 47, minus 40. We get 7 over 2. And sure enough, this matches what we got last time. So yeah, this is another way to do this kind of problem. Of course, as you saw, to do it with the circle and find an antiderivative was much longer than the way we did it the other way. This way is actually pretty short. So yeah, you can do it this way if you want, but on the test, it's probably faster to just do it with the definite integrals the way we did last time.